Hello friends, welcome to this video on set theory. This video will talk about the closure of a matrix, and this is going to be the 10th video in the series of set theory. Come on, we will now see what is meant by closure of any relation. If R is going to be a relation which has been defined on the set A, and we happen to have R to not satisfy any particular property, then we can find the smallest of the relation R1 on the set A, so that R1 possesses the desired property and also contains R. This new relation R1 which is being formed is called as the closure of R. So the base is like R is going to be there, the relation has been defined on a particular set A, but R does not possess any property which we desire for. So what we do a topping on top of it. So this topping which we do is going to give us a new relation, and this topping or this add-on is going to give us a new relation. This new relation is going to be R1. This R1 is going to be the old relation R and the desired relation which we want for. So this relation which we get, new one, will be called as a closure. It's something like our ice cream. We get the base ice cream which is going to be vanilla or chocolate. On top of it we are going to add some chocolate syrup, or we are going to add some nuts on top of it, or some sprinklers on top of it, something of that sort. So that is going to be like our desired flavor. So we get a basic car or a basic bike, but that may lack some amenities which we may desire for, like flashy lights or stereo systems or something of that kind. So to the base car or the base bike which we have got, we are going to add on or do a topping of our desired quantities to make things which is going to be of our kind. So the new resultant will be called by the name called as closure. I hope you understand the definition of closure of a relation. Now there are going to be various types of closure, where we can classify them as reflexive closure, symmetric closure and transitive closure, the more commonly used of all. So what is meant by reflexive closure? If you want R to have the basic property of reflexivity to be included in it. What do you mean by reflexivity? In relationship, we know that A comma A belongs to R for all your A belonging to the set, then it is called as reflexivity. Now if your base R does not have all the points A comma A, what I do is I top it up with my reflexive nature. This reflexive nature is denoted by the symbol called as delta. Delta happens to be the collection of all A comma A such that A belongs to the set A. So when I do a topping of this existing relation with this delta, then what happens? Automatically my desired elements of the format A comma A gets added up to your old relation. This new relation which we have is called as reflexive closure. What is meant by symmetric closure? The relation R1 which we have, which is got by topping up your old R with your R inverse. Why an R inverse? Because we know that if R is going to be the relation of the ordered pair A comma B, then what do you mean by symmetricity? We need to have B comma A also to belong to the relation. But how to get this B comma A? This B comma A is got by your R inverse. So this R inverse is the collection of all the points of the format B comma A whenever our A comma B belongs to the relation. So what do we do is, if our original set R lacks its inverse element, we top it up with R inverse and then form the new relation R1, which is the union of R and R inverse. So this R inverse provides the inverse elements of all your x comma y which is already present in your R. This new relation which we get is called as symmetric closure. In a similar way, we can go for the transitive closure too. So what is meant by transitivity? You know that whenever we have A comma B to belong to the relation and B comma C to belong to the relation, then A comma C also belongs to the relation. So AB is related to BC and BC will now have a relation that moves from A to C. So that is how we build a new relation. So if this transitivity is missing, then we can add on more of these numbers by taking the joint of the matrices MR, MR square, MR cube and so on. So this union of all these things will add up to the transitivity relations, generating the new matrix which is going to be defined as MR infinity or MR plus. This will satisfy the transitive closure nature. So this is how we do add on the existing relation to get the desired relation. This new relation is called by the name closure. So now come on, let us try our hands on solving or finding what is going to be the reflexive and symmetric closures of the given relations. A be the set 1, 2, 3, 4 and R1 and R2 be two relation which has been given. R1 is 1, 1, 1, 2, 2, 3, 3, 4 and R2 is some other relation. So first let us begin with R1 which has 1, 1, 1, 2, 2, 3 and 3, 4. Now we need the reflexive closure of R1. Reflexive closure. How do we give this? With your R1, you add up the closure elements delta. What are our closure elements delta over here? My set is A is 1, 1, 2, 3, 4. So I have 1, 1, 2, 2, 3, 3 and 4, 4 to be my reflexive closure elements. My delta has been got. My R1 is here. So I take the union of all. So 1, 1, 1, 2, 2, 3, 3, 4 of your R1 which is existing and I top it up with this delta. 1, 1 is already present, so we ignore. I introduce 2, 2, I introduce 3, 3 and I introduce 4, 4. Now this new relation which we have here contains all the elements of reflexivity. Hence you call this to be reflexive closure. Now let us move to the symmetric closure. So how will we get a symmetric closure? A symmetric closure is obtained by taking union with its inverse. So what is going to be the inverse of R1? So now my R inverse is going to be the flip of my elements. 1, 1 on flip is going to be 1, 1. 1, 2 on flip is my 2, 1. 2, 3 on flip is my 3, 2. And 3, 4 on flip is my 4, 3. So I have my R1 and my R1 inverse. And when I now take the union of them, I have this to be equal to 1, 1, 1, 2, 2, 3, 3, 4. And now include these elements. 1, 1 is already there, so ignore. And so you include 2, 1, 3, 2 and 4, 3. Now we notice that all the elements over here have their inverse also to be included in it. And hence this new relation which we have got here is called as the symmetric closure. Now we have tried this for this relation R1. I hope you friends can try it for the relation R2 too. Can we? So I have the relation R2 given by 1, 2, 2, 2, 1, 2, 2, 2, 3, 2, 4, 1, 3, 2, 4, 1 and 4, 4. Now what is going to be my reflexive closure? Then it is R2 union your delta. So I have 1, 2, 2, 2, 3, 2 4 1 4 4 to include elements 1 1 of delta, 2 2 is already there, 3 3 of delta, 4 4 is already there. So now this set includes all its reflexive elements and it's called as the reflexive closure of the relation R2. How to get your symmetric closure? So now this is going to be R2 union R2 inverse. So let us first write what is going to be R2 inverse. The flip of the elements 1 2 as 2 1, 2 2, 2 3, 1 4 and 4 4. Now let us take the union of these elements, which is got by 1 2, 2 2, 3 2, 4 1, 4 4, the base of R2, and its inverse flipped 2 1, 2 2 is already there, so we ignore it. 2 3, the flip of 3 2, 4 1's flip, which is going to be 1 4, and 4 4's flip is already there. So now all the inverse of the elements present inside the set are inside this new relation form, and hence we call this to be a symmetric closure. Transitive closure is not as easy as a reflexive or symmetric closure, and hence we have a special algorithm defined for your finding of transitive closure called as Warshall's algorithm. We will see about Warshall's algorithm briefly in our next video. I hope this gave you an idea of what is meant by closure and how to find reflexive and symmetric closures. Happy learning. Keep continuing learning. Thank you.